Today we're gonna have a tutorial of explaining how a simulation of an Eclipse program works. We're gonna use a simulation program created by the NASA. As you can see, it's a very detailed and specific program. It shows here the eclipse that occurred this year, 21st of August of 2017. From many different, I mean, you could study this phenomena from many different parts of the world. However, we're gonna only focus on North America first of all because I'm a college student there, more concretely in a town named Bolivar, very close to Kansas City. So, we're gonna focus on how the eclipse was seen there in that zone, and also because we have 100% coverage of the sun in Kansas City. So that's an eclipse is a very limited phenomenon to see in the natural world. That's why a simulation program created to explain how this phenomena works is very important, and it's also very important to see how detailed and specific and accurate and precise the simulation program is. So first of all, we're gonna start showing here that there are different locations where you could see the eclipse from: Miami, Los Angeles, but as previously mentioned, we're gonna focus on Kansas City. Second of all, here we have the percentage of the sun coverage. So, for example, if I run the eclipse now, we're gonna see it. I'm gonna run it faster. Here is in Kansas City, so we're gonna see Kansas City is in the line. As you can see here, it's in the line of 100% coverage. So we can see that the sun is fully covered at this point. Here on the right side of the screen, we see the percentage of sun coverage, which matches with this percentage in here. So now here in Kansas City, it's in the line of 100%, so the coverage is 100%. However, if we move to Los Angeles, if we move to the location to Los Angeles, we're gonna see that at the same point of the eclipse, the sun is not fully covered because the Los Angeles is in the range of between 75 and 50% of coverage. This is a very important point in order to have a fully developed study of the eclipse, because basically the eclipse is studying the coverage of the sun. So the more the sun is covered, the better the natural event is. So here we could also add a location, for example, Barcelona, which is where I'm from. We add here Barcelona, and then Barcelona has been added. So now the location is here. As you can see, the red dot here in the screen represents Barcelona. So since the eclipse was not in the range zone of Barcelona, we wouldn't observe anything. Nothing happens in Barcelona because the eclipse couldn't be seen from there. Okay, another very important and very detailed presentation. I mean, not presentation, but aspect that this simulation contains is that it allows to see the eclipse. I'm gonna come back to Kansas City, the location, which is the best one. It allows to see the eclipse from very different perspectives. For example, now we are observing the eclipse from the moon perspective. From the moon perspective. So that's how the eclipse would look like if we were in the moon. Actually, I'm gonna make it run faster, because otherwise we don't see anything. Here we see the coverage, but since we're in Kansas City, we have 100% coverage. Here's the Earth. So, and if we rotate everything, we see we are basically observing the perspective, the eclipse from the moon here. The complete rotation of the Earth, so we're observing the eclipse from the other side. So here's the moon perspective. So we're observing what occurred during the eclipse in the moon. There are several other perspectives. For example, here, this one is like a more global picture of the event, because it shows the relationship between the Earth, the moon and Sun. The scale, as it says here, is exaggerated because obviously it's not like this, but it can give you, it can give a like a very good picture of how everything is aligned during the eclipse, during the time of the eclipse occurs. Yeah. So here is another perspective. It's the perspective from the Earth to the Moon. The one that we previously observed was from the Moon. So here is like the system created by the Earth and the Moon. And as we can see, this purple line that appears here in the screen represents where the shadow in the Earth appears, which is exactly, it matches exactly with the ranges of coverage that we observed, that we previously observed from the Sun. And we're gonna come back to the initial perspective, yeah, and we're gonna just comment briefly the advantages and disadvantages of this simulation. It is actually a very accurate simulation of what is happening during a solar eclipse, and obviously it's not 100% realistic because it's a simulation, as the name indicates. It simulates a natural it simulates a process. So, but however, we have to accept, and it's obvious that it's a very good and detailed simulation that can give very accurate information to the astronomers and physicists and whoever is interested in eclipses. Another advantages from this simulation program is that it allows to manipulate and see as many times as you want a natural event that occurs very limited times during a year. So there are solar eclipses only. There are years that there are no solar eclipses at all, which means that this program allows to study a process that you cannot see every day, which is something very good. And however, one disadvantage of this program is that obviously, first of all, it's a simulation and it's not 100% realistic, as I previously mentioned. But another disadvantage is that it is only a simulation of the eclipse that occurred the 21st of August of 2017. And even if the eclipse events that occur during whenever, during the nature or during the X period, are very similar. They have very similar characteristics because it's a very similar process every time it occurs, and they are not the same. So this simulation is very good to observe and understand the principal characteristics of solar eclipse. But if you want to go more in detail in any other eclipse that occurred before or that wants to occur in the future or that will occur in the future, this program, you cannot rely 100% on the information that is given from this program. Thank you very much for listening and for joining me with this live simulation of the Eclipse program. I hope you enjoyed it and I hope it was useful. Thank you.